Humans use mental shortcuts called heuristics to overcome our brain's limited processing power and solve problems efficiently. These heuristics are useful, but they sometimes lead to mistakes, and when this happens, we call them biases. Cognitive biases are thought processes that skew judgments and perceptions. They're easy to ignore, so difficult to control. Let's consider an example. Consider the letter R. In English, is R more likely to appear in the first position or the third position? Choose one. Take a minute to think about it and write down your answer. This question was given to 152 participants in a classic series of studies in the 70s by Tversky and Kahneman, who later won the Nobel Prize for this work. What's the answer? It's the third. Is that what you chose? Probably not. Most people, including 69% of these participants, incorrectly guessed first position. They also guessed wrong for K, L, N, and V, which are more frequently found in the third position as well. Why do people make this error? Well, it's way easier to think of words that begin with a letter compared to other positions in a word. Focusing on how words sound at the beginning is how we learn to speak and read. Rake, robbery, rabbit, and retriever come more quickly to mind than marriage, darkness, carbon, and purity. In fact, it took me about 3 times as long to come up with the second list out of my head. This tendency to solve problems based upon how easily we can pull information into our awareness is called the availability heuristic. Another type of cognitive bias is what I call the hockey fan effect. Let's say you and a friend are watching a riveting hockey game. You're both huge fans of opposing teams. It's the final, the game is tied, and you both bet money that your team will win. With 3 minutes to go, the ref makes a call on the star player of the black team, sending them to the penalty box, giving the white team, your team, an advantage. Even though you and your friend both received almost identical information from your visual and auditory systems, it's likely that you're delighted and your friend is upset. This is probably due to the confirmation bias, when people only look for evidence to support their beliefs and don't try and disprove them. Even though you saw the same thing as your friend, you looked for different evidence in making a judgment about the fairness of the ref's call. The hockey fan effect can be predicted by team loyalties, but careful scientists are humans, just like hockey fans, so sometimes these cognitive biases creep into research. Let's consider one famous example. In an unusual field study, David Rosenhan had 8 sane pseudo-patients, 3 women and 5 men, go to admissions at 12 different hospitals across the US. They claimed to hear a voice of the same gender saying the words empty, hollow, and thud. Other than this lie and using false names to conceal their identities, the pseudo-patients behaved normally. All 8 were misdiagnosed with schizophrenia and admitted. The length of stay was on average 19 days, but ranged from 7 to 52. Rosenhan instructed his brave volunteers to document their experiences, which initially they kept hidden, but soon learned that no one really paid attention, so they were able to take notes out in the open. This table shows the responses from healthcare providers at different types of institutions when approached by a pseudopatient. At psychiatric institutions, which should be best equipped to treat mental illness, only a small percentage of the psychiatrists, nurses, and attendants stopped to talk. Most looked away and moved on. In contrast, at university campuses and medical centers, most faculty and physicians stopped to respond to questions from the pseudopatient. This was not a fantastically well-controlled study. Rosenhan used a very small number of participants, and the measures they took were not clearly defined, so this study's methods and ethics have been the target of criticism. However, the very fact that 8 psychologically healthy individuals trick their way into psychiatric institutions by telling a few lies is proof in principle that diagnoses can be biased. So how can we avoid cognitive biases? This is challenging, since it means examining your own thought processes and prejudices. It's almost as impossible as smelling your own smell. You're always with you, so you become accustomed to it and can't detect it. However, by learning about common cognitive biases and trying to think outside the box, it's possible to minimize the impact of this type of bias. Test yourself. What are some ways to reduce cognitive biases in research? Think of as many as you can, be specific. So clearly, biases are a threat to the collection and interpretation of data. So scientists take great care to reduce bias as much as possible.